Okay, so the definition of a circle. It's a collection of all points that are equidistant from a fixed center point. So really, the only word in here that's kind of new to you may be equidistant, but I bet you can figure out what equidistant means. Equal distance, right? So it's a collection of all the points that are equidistant from a fixed center point. Okay, so if you'll remember back to last week, we talked about the distance formula. Does anybody remember where we derived the distance formula from?
2 points.
We took 2 points and we used what to find the distance formula?
X and Y.
Right, but remember, we did it for a generic X and a generic Y.
Yeah.
We said, well, if this is a point, say this is X1, Y1, and this is a point, X2, Y2, and I want to know this distance. How did we find that distance? Do y'all remember?
We put it in the formula. It's square. Pythagorean theorem.
Yes, the Pythagorean theorem. That is how we found that earlier, if you'll remember. You can check my videos. They're on YouTube. That's how it happened. So, we're going to do the same thing here to find the equation of a circle. Right? It's the same process. So, I've got some center point. We're going to call that center HK. Okay? And this distance that I'm looking for is the radius. Remember before we just called it a distance D? Well, now it's the radius R. And we picked some arbitrary point on the circle and we said, here's a point XY. So now, let's use the Pythagorean theorem to see what formula I could use to get a general form for the equation of a circle. Now first, let's look at this side length. What's the length of this blue side here? Okay, the y values are from k to y, so what's the distance between them? Remember when we had the 2 guys? We had a guy that was 6'3" and a guy that was 5'9". How did you find the distance between them? Like, what's the difference in their height? You subtract. So how can I find the difference between y and k?
Y minus K.
Very good. So this side here is the side length y minus k. Okay, now similarly, on the bottom, right, the x values go from x to h. So that distance is x minus h. And I kind of drew my, it has been clear if I'd have drawn my triangle the other way. Let me do that very quickly so it looks right. My fault. Okay. So if I draw it this way. Now then, we've already talked about this was y minus k. And now you can see here, this is all the way to x, and then we have to back up a little bit to h. So that distance is x minus h. Does everybody see that?
Yes.
I just didn't want to put it up here because I would have to draw over that, but that's fine. Now, I know the 3 side lengths. How can I connect all 3 side lengths with a formula? Well, it's a right triangle, so we can use the Pythagorean theorem. Thank you again for that wonderful screen. Now, the Pythagorean theorem. It doesn't matter which one is a and b, for a squared plus b squared equals c squared, but the radius here has to be the c. So I know it's going to be it equals r squared. Okay? I'm going to let this side be my a. So I have got x minus h squared plus y minus k squared. And I'm going to say that that equals r squared. This here is the general form of an equation for a circle. You probably want to write that down. We're going to use that a lot this section. Now here on page 45 in your books, they talk a little bit about the different forms, the different equations of a circle. Right here, the top one is the one we just looked at, right? The center is HK, R is the radius. Now, what if the center of my circle was the origin? Then what would H and K be? 0, 0. So then if this was 0, 0, then I would just be left with x squared plus y squared equals r squared. Right? Good. Which again, yes, looks just like Pythagorean theorem. And then the last one says, okay, well, what if the center was the origin, and what if the radius of my circle was 1? Okay, well then we would be x squared plus y squared equals 1. This here, the circle whose center is the origin and whose radius is 1 is the unit circle. And that's something we will use a lot after Christmas when we get into trig. So it's just doing a little introduction of it here. Okay, now, we're given some information about a circle, and we're told to write it in the standard form of the equation of a circle. So what am I given? I am given the radius, and I'm given the center. I just have to plug it into that equation. So again, the equation is x minus h squared plus y minus k squared equals r squared. So my equation would look like x, okay, minus h. My h value is negative 3. So that's going to be plus 3 squared plus y minus k 6 squared equals the radius squared. What is 5 squared? It's the general form for the equation of a circle. So that is taking the center and the radius and putting it in an equation. The next example is doing the exact opposite. Okay, so now in this one, we are told to graph the circle. So in order to graph the circle, what things do I need to know about this circle? I need to know the radius of the circle, and I need to know the center of the circle. So let's identify those from the equation.
The center is 3, 2.
It is not 3, 2. The center is...
Negative 32.
Very good. Negative 3, 2. Remember, there's a built-in negative to the formula. So since this is positive 3 here, it's a negative 3 that's actually the center. And since this is negative 2, it's a positive 2. Good. And what is the radius of my circle?
4.
4. Very good. Any questions about finding the center and the radius?
No.
Everybody can do that. Now, to graph it, first we go to the center and plot a point. So the point's at negative 3, 2. Let's plot that point right there. Okay, if my radius is 4, well, what does that mean? If I draw a straight line 4 units in any direction, it should be on the circle. So what are the easiest directions to count on a grid like this?
Up, down, left, and right.
Up, down, left, and right 4. So that's what I'm going to do. I'm going to go up, down, left, and right 4, and then connect all those to make my circle. Okay, so as I go right 4, 1, 2, 3, 4, my point should be right there. Ooh. That's all right. Now go up 4. 1, 2, 3, 4. It's not easy to draw with this thing. Left 4. 1, 2, 3, 4. Oh no. Oh no. I can't go left 4. I can't see it. And go down 4. 1, 2, 3, 4. I know it looks like it can on your screen. There's a bar in the way on mine. I can't move it. Okay, so I take those points. I just have to connect them. That's ugly.
I don't guess you're good at those connected dot colors.
I'm not. I never was a good drawer.
I'm not either.
Do you get the general idea of how to draw a circle? And do it better than I did. Okay. Okay, so now we are doing some things that we've done in this chapter up to this point. So now we know how to create an equation given the center and the radius, and we can find the center and the radius given an equation. Well, now this wants to know, what are the intercepts of this circle? Well, I don't know how to find intercepts. I don't remember. Can anybody help me in identifying how to find the x-intercepts? How could I find the x-intercepts?
0 and for y.
It's amazing that we're still doing that, right? Get used to it. You're going to be doing a bunch. So, the x-intercept is found by plugging in 0 for y. So let's do that. That gives me x plus 3 squared plus 0 minus 2 squared equals 16.
So it's going to be x plus 3, x plus 3.
Okay, I'm just going to leave it as x plus 3 squared for right now. Plus, okay, this is negative 2 squared, which is 4, equals 16. Now my goal is to get x by itself. Right, so I'm going to move the 4 over. It becomes negative, so that gives me x plus 3 squared equals 12. Now why is the x not by itself?
No, square root that.
Well, it's being squared right now, so how can I undo squaring something?
Square root.
Square root of both sides. So the square root of something squared, those are inverse operations. And I'm left with just x plus 3. I don't know why I put the parentheses. Drop those. And now what just happened? I chose to take a square root of both sides. So I have to
Plus or negative.
account for the plus or minus.
2 radical 3.
Very good. Now the x is not by itself because there's a plus 3. So I move it over.
So it's going to be negative 3 plus 2.
Excuse me, teacher. Say have your
Plus or minus this 2 radical 3. So how many x-intercepts do I have?
I don't even know.
2. What are they?
Negative 3 plus 2 radical 3 and then negative 3 minus 2 radical 3.
Very good. Now you can find what those numbers are by putting that in your calculator. It'll give you an approximation. Like what is negative 3 plus 2 radical 3? That is approximately...
0.4641.
Okay, so it's just past the x value of 0, right? Just on the positive x-axis. And if you graph this, you can see that that's exactly where it's at. Okay, now let's find the y-intercepts. The y-intercepts are found similarly. How do we find y-intercepts?
Plug 0 in for x.
Very good. So this is 0 plus 3 squared plus y minus 2 squared equals 16. So that's 9 plus y minus 2 squared. 16, move the 9 over, it becomes negative. Y minus 2 squared equals 7. Square root of both sides.
Y minus 2 equals plus or minus radical 7.
Very good. And then move the negative 2 over.
Negative 2 plus or minus radical 7.
It's not negative anymore.
Positive 2.
Very good. It's going to be positive 2 plus or minus the square root of 7. So I have 2 y-intercepts as well. Let's think about it for a second. If I'm graphing x and y-intercepts, can I ever have more than 2 for a circle? Could you have more than 2 x-intercepts for a circle? How?
So one positive and one negative?
That's 2. How can you have more than 2?
Oh, never mind.
How can you have more than that? Could you have more than 2? No. Could you have 1?
Yes.
You could if the top or bottom happened right at the x-axis. And could you have 0? Yeah, I mean if it was way up out of the way, right? But you can never have more than 2 x-intercepts or 2 y-intercepts
So you
of a
always
circle.
have y. No, never mind.
The way I look at this... Okay, so this problem here is what's called the general form of a circle. You won't hear me use that a lot. But basically, your x's are separated and your y's are separated. And we want to rewrite this to make it look like x minus h squared plus y minus k squared equals r squared. Okay, so in order to do that, I need to group my x's together, my y's together, and then get the constant to the other side. So I'm going to do that here. I'm going to rewrite this as x squared plus 4x. Then I'm going to leave a little blank space for something I'm going to use here in a second. Plus, here's a y squared minus 6y. Same thing, I need another blank space plus that. Okay, and I'm going to say that this is equal to, I'm going to move the 12 to the other side, it becomes negative. So that's equal to negative 12. Now what we're going to do is we're going to complete the square with both the x squared and the y squared terms. This becomes much easier when the coefficient in front of my x squared is 1 and the coefficient in front of my y squared is 1. So in this case it is for both, so it becomes very simple to know what to add to both sides. Okay, we're going to look at this b term. Here it's a 4. We half it to get 2, and then square that to get 4, which means I'm going to add 4 in that position. Now look at the y squared term. Leading coefficient is 1, so look at my b term. It's negative 6. Half it, that's negative 3. You square that, you get 9. So I added 9 in that position. So now what have I done to the left side of my equation? I've added a 4 and a 9, which is the same as adding 13. So I must do that on the right side as well to keep the equation balanced. Okay, this factors to be perfect square trinomials. So if you see that, you can go ahead and factor it. If not, remember a times c, we split the middle term up. It's going to be 2x plus 4. And the great thing about doing it this way is we know since they're perfect square trinomials, this b is always going to split in half. So 2x and 2x. So let's do it again on the other side. This 6y is going to split to be negative 3y minus 3y plus 9. Now factor by grouping. So that's going to give me x times x plus 2 plus 2 times x plus 2. Over here I'm going to factor by grouping. So the GCF of the first two is y. That leaves me with y minus 3. Then here the GCF is negative 3. Sorry. I should have put the parentheses yet. It's minus 3. That leaves me with the y minus 3. So now what have I factored this to be? Remember, it's what's in front of the parentheses. So it's x plus 2 times x plus 2 plus y minus 3 times y minus 3. And again, this equals negative 12 plus 13 is 1. So I'm going to bring that down now. And then, well, what is this? Well, x plus 2 times x plus 2, that's the same thing as x plus 2 squared. Similarly, this is y minus 3 squared equals 1. So now look how I've taken the general form of a circle, and it's now written in the standard form of the equation of a circle. Good. Now, when it's in this form, it's easy to tell. My center is negative 2, 3. Remember, we get that from the opposite signs of what's in parentheses here, my h and my k. And then the radius is going to be equal to the square root of the constant term. In this case, the square root of 1 is 1. So now given the center and the radius, I can go ahead and graph this. Okay, so as I graph this, the center is at negative 2, 3. So I'm going to go ahead and plot my point there. And then the radius being 1 means I'm going to count right, left, up, and down in 1 unit and put those points. So that was pretty simple in this one. So right here is 1 down, 1 right, 1 up, and 1 to the left. And on my circle is going to go through all of those points. So in this one, with a radius of 1, that's a rather small circle. And right there it is. Okay, now this one here tells me to write the general equation of a circle. Now, I'm not going to ask you to do that. I do not think the general equation is important. So instead, we will look for the standard equation of a circle. Okay. So let's do that now. It tells me the center of that circle. That's good. But then it tells me it contains this point. So what am I missing? Well, in order to write the standard equation, I need the center and I need the radius. So I need to find the radius given the center and a point on the circle. So now that I know the center and a point, I just need to know the distance between the center and a point on my circle, because that will give me the radius. So how can I find the distance? Well, we're going to use the distance formula. That gives me the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, so I'm going to say that this is my x1, my y1, therefore this is x2 and y2. I'm going to plug in right here above it. So it's going to be x2 minus x1 squared plus y2 minus y1. So minus negative 2 is plus 2 squared. Okay, simplifying that, that's going to give me the square root of 3 squared plus 0 squared, which is the square root of 9, which is 3. So the distance from the center to the edge is 3. That means that the radius of my circle is 3. Okay, so given the radius and the center, I can write standard equation of a circle. So this is going to be x minus x1 squared plus y minus y1 squared equals the radius squared. So that's 3 squared, which gives me 9. So this is the standard equation of a circle.